So in this next segment, we're going to start talking about buffers. First, we'll talk to set this up to talk about the common ion effect, which is really just another manifestation of Le Chatelier's principle. We'll calculate how addition of common ions change the pH, and then we'll look at these ideas that we've seen and understand why buffers work. And calculate the pH of a buffer solution and learn how to do that in a general case. Okay, so first we're going to sort of touch on these ideas looking at the common ion effect. And what this is saying is, let's say I've got acetic acid, I dissolve that in water. So this dissociation occurs. How will the pH change if I add sodium acetate to this reaction? I mean, before I had acetic acid, so in theory, I didn't add any acetate in, I just added acetic acid, but of course it creates acetate. So the question is, how will the pH change if I add that sodium acetate to the reaction? So pause and think about it for a second. Okay, we're back. So I sort of hinted at this when I said using Le Chatelier's. So if I'm adding sodium acetate, that means, well, sodium acetate is soluble. And so I'm essentially adding acetate. If I'm adding acetate to the solution, if I've added this, it has to go backwards. And if it's going backwards, that means that it takes H3O plus out of solution, which means the pH has to rise. It becomes more basic. Another way to think about that is that sodium acetate is the salt of a strong base and a weak acid. So it's a basic salt. So that means it will remove H3O plus as well. So there are two different ways to think about it. But that's all it is when the common ion effect is referred to. So let's, so as you add acetate, your concentration of H3O plus will go down and your pH will rise. And it'll look something like this. You can calculate the equilibria using some of the same ideas that we've looked at before, but that's essentially what happens.